Assalamu alaikum everyone. A lot of people have said that they did not understand how linked lists work actually, but they did not ask any questions after my lectures. So I guess I have to start again, or at least go through the basics again. So this is my third linked list lecture, and throughout this lecture my layout is going to be like this. At the very left part of my screen there will be the code blocks code of linked list, which contains all the 4 required functions: edit node, painting the node, deleting nodes, and inserting nodes. And as you can see, the structures are created and everything. So the interface here is, it will be printing 5 things. The first one is an option to add a node, the second one is an option to delete a node, the third one to edit nodes, the fourth one to view nodes, and if you press 0 then the code will exit. Okay, so the interface will be something like this. As you can see, it's sort of like the interfaces that you have been told to create in some of your labs. So the first choice, when the first choice is given, this interface will be turned on and the insert node function will be called. For the second one, the delete node, and so on. So this is nothing new, you already know this. And at the very right part we'll be explaining everything as we go line by line in the codes. Okay, so let's start at the very beginning. We have a new pointer of the structure type node, and if you can remember, we have already been through this. This is the structure node which has an integer key and another structure pointer of itself which can point to the next node. Okay, so then what are we doing? We are assigning an allocated memory equal to the size of node structure, and we are allocating that memory to this head. Okay, so what happens is, we have a structure pointer head, then we allocate a new memory for it which is equivalent to a node structure. Okay, so then what are we doing? In the next line we can see that we are assigning the value null to the next pointer of that head, and we are assigning the head key value to the key of this head pointer. Okay, so the head key is minus 333, if you can remember. So we are using that value because we will not be using minus 33 in our experiments. Okay, so what happens? We are assigning the value minus 33 inside the node, and then we are saying that this head is pointing to null. Okay, so as we can see, after that this whole screen runs. That means we are giving the choices, so we can choose whichever option we want. So I'm going to add a node. Okay, so what will happen if I add a node? Let's say I want to add a node with the key value equal to 4, and as you can see, our function insert node uses these 2 variables, the head and the key. Okay, so once we enter a choice of key value 4, this function will be called insert node with the head pointer and the key value. So then let's continue with our insert node function. Okay, so here what are we going to do? We're going to insert 4, and again the interface comes on. So what just happened when we inserted 4? Let's see. So here inside the function insert node, a new temp node structure pointer is created. So let's create the new pointer which is called temp, and then we are assigning the value key inside this temp key, right? And the key value is 4. As we have already passed this into the function, this key value already contains the value 4. So after allocating a fixed amount of memory for temp, we are assigning the value key to the key variable of this temp, and then we are saying that the next pointer is pointing to null. Okay, so the next pointer is pointing to null. So then what will happen? After these 4 lines are executed, this while loop starts executing. So inside the while loop, the first condition, or the actual only condition, is head next not equal to null. So until my head next is not equal to null, this while loop will keep on traversing, or will keep on looping. Okay, So is my head next equal to null? Yes, currently my head next is equal to null, right? So it will just break, it will not get inside the loop. And after that, what is the next line? Head next is equal to temp, right? So which is my temp? This is my temp. So what am I supposed to do? This head next will be pointing to temp. Okay, so the null will be erased and this head will be pointing to temp. So after the function terminates, all the variables are deleted, right? The head, the temp, the null, everything. So once that happens, the entire node is something like this. Okay, so let's see whether it's actually this or not. So what are we going to do? We are going to view the nodes. So once we view the nodes, as we can see, it's printing minus 333 and 4, which is exactly what our linked list should be. Okay, so next we are going to assign a new variable or a new key value, which is 1. Okay, as you can see here, I've changed the key value to 1. So then what will happen? Again, the same function will be called, but now the key value passed will be 1, and the head is again at the very beginning, because if you can remember, this head is the head of the main function, which is always pointing to the beginning of the linked list. So inside the function, again the head will be started from the very beginning, and again a new temp will be created. So the new temp is created, temp pointer, and then memory is allocated to it according to line number 15. So new memory is allocated. Then what are we doing? We are saying that the key value is equal to the key that is passed into this function as a parameter. So the passed parameter is 1, right? So we are supposed to place 1 inside the temp variable. So this temp 1, this temp variable key is equal to 1, and the next pointer is supposed to point to null, right? Just line number 17. So the same thing happens here. Again we start with the loop. So while my head next is not equal to null, it will continue. So now currently my head is pointing to minus 333. Is the next of head equal to null? No, right? It's pointing to 4. So what will happen? This line will be executed, which is head is equal to head next. So the head will now be pointing to the next of the previous head, which is 4. So now again the while loop condition will be checked. Head next not equal to null. Is it true? No, it is not true, because my head next is equal to null. So now it will not get inside the loop, it will break from the loop. And now what will happen? Head next equal to temp. This line will be executed. So my head next is actually pointing to null. So now it should point to temp. So what will happen is the null will be erased, and now 4 will be pointing to temp, which is 1. So after this function terminates, again the variables will be removed, and this will be the new linked list. So let's see whether it's actually working or not. So we want to again add a node. So enter key of node to be added. So we want to add 1, right? So we have added 1. Now if you want to view the nodes, this is what we get: minus 333, 4 and 1, right? This is my linked list, as you can see. Okay, so for insertion I'm going to add one more node so that it's clear for you to understand. So now I'll be using another key value, which is 7, right? So once again the function is called, everything will start from the very beginning. So a new temp will be created just like before. The value will be given 7, and the next pointer will be pointing to null. So this is my temp. Now what will happen? As the function has started from the very beginning, the head should be pointing again to the beginning of the linked list. So now what are we going to do? We are going to traverse the while loop. So while my head next not equal to null. So is my head next equal to null? No, it is actually equal to 4, right? So the head should now equal to head next, which is 4. So my head will now point to head next, which is 4. Again I will check in the while loop condition, is my head next equal to null? No, it is still not equal to null. It is equal to 1, right? So again it will loop through So my head will now be pointing to 1. Now, is my head next equal to null? Yes, it is equal to null, right? So this head next not equal to null, this will be false. So the while loop will break. And now my head next equal to temp. This line will be executed. So let's see what happens. The null is erased, and now head next is pointing to temp. So once this function terminates, this is my entire linked list. So this should be the result of the code, right? Let's see whether it's the result of the code or not. So we want to insert the last node, which is 7. So I'm going to give 1, which is for add node. Then I'm going to enter the key of the node, which is 7, right? So let's print the node again. So 4 is for viewing the nodes. So as we can see, it is printing minus 333, 4, then 1, then 7, which is the exact same order as there is in the linked list. So it's working properly, okay? So this was insert node. Now let's move on to delete node, okay? So this is the entire linked list as before, but instead of entering a new node, we are going to delete a new node. And as you can see, the deleting also works in the same way. It takes the input of the key that I'm going to delete here, and then it passes the head and that key that is going to be deleted, okay? So we are going to go into the delete node here. This is our delete node function, and as you can see here, there are the two previous variables, head and key, but there is a new variable which is prev or previous, okay? So this is a new node pointer. So we are going to use this to work, okay? So let's see. At first we have the variables key, the variable previous, and the variable head. So at first we want to delete the value 1, okay? So where is the value 1? Here. Let's see what happens. So when the function is called, the head is pointing to the very beginning of the linked list as usual. Then the key is passed, which is 1, right? Then what happens? The new pointer previous is declared. Then it gets inside the loop. So what is the condition of the loop? If my head next not equal to null. So is my head next equal to null? No, it is equal to 4, right? So this is true. It will get inside the loop. Now inside the loop, if my head key is equal key, so the key is 1, right? But my head key is minus 333, so they are not equal. So this will be false and it will not break. So the loop will continue. Previous is equal to head. So what will happen now? The previous will be pointing to the head. Then head is equal to head next. So now head will be pointing to head next, which is 4. Then again the loop will start from the very beginning. Now again this condition will be checked. Is my head next not equal to null? Yes, it is not equal to null because my head next is actually equal to 1. So what will happen now? We'll get inside the loop. If head key is equal to key, then break. So is my head key equal to key? My head key is equal to 4, but my key is equal to 1, right? So they are not equal. So this will not break. Again the previous will be equal to head. That means the previous will now be pointing to head, and the head will be pointing to head next, right? So the head will be pointing to head next, which is 1, and again the loop will start from the very beginning. So the condition will be checked again. Is my head next not equal to null? Now in this case my head is 1, right? And my head next is equal to 7. So even now my head next is not equal to null. So we'll get inside. So head key is equal to key. Which one is my head? This one is my head. What is the key value? 1. And what is the key that is passed to me? 1, right? So now in this case they are equal. So this condition will be true for the very first time now, and the loop while loop will break. So then this condition will be executed. So what is this condition? Let's see. Head next equal to null, which means my head next should be equal to null, but my head next is not equal to null, right? So this is false. It will not get inside. But what is the other part of it? If my head key is not equal to key, so this means that if I am at the very end of the linked list. That means my head next is equal to null, and my key value is also not equal to key. So I'm at the very end of the linked list, but I did not find the key. So in that case, it will actually print the key is not found, and then it will return from the function. It will not do anything else. Okay, so in this case we actually found the key, right? We found 1, so this will not be executed. The next lines will be executed. So what are the next lines? Previous next is equal to head next. So which one is my previous? This is my previous, right? And my previous is pointing to 4, and my previous next is pointing to 1, and my head next is pointing to 7. So this line is saying that my previous next, that means 4, should be now pointing to head next, which is 7. So this is going to be executed. Then the next line is free head. That means the head part is deleted or freed. The memory for this head is freed. So this will be freed. As you can see, this becomes the entire linked list now. So it should be minus 333, 4, then 7. So let's delete a node 2. And what is the node to be deleted? The key value 1, right? So we have deleted it. Okay, fine. So if I want to view now, what will it print? Minus 333, 4, and 7. So as you can see, this entire linked list was printed properly, and just one value from the middle is missing, which is 1, the one we just deleted. Okay, so I'm going to show you another deletion which actually uses this part, so that you can understand what is the functionality of this part. Okay, so this time we are going to delete the very last element of the linked list, which is 7. Okay, so again the function will be called with the head pointer and the key value equal to 7. So now what will happen? The entire function will restart. The head will be pointing to the very beginning of the linked list, and previous will not be pointing to anything. Okay, so now we get inside the loop again. So while my head next not equal to null, my head next is not equal to null, because my head next is pointing to 4, so it will get inside the loop. Now if head key is equal to key, so my head key is equal to minus 333, so it is not equal to the key value, so the while loop will not break. The next line will be executed, which is previous equal to head. So what will happen? Previous is equal to head, which is actually minus 333, and then the next line is head is equal to head next. So head will be pointing to head next, which is 4. Then again the loop condition will be checked, which is head next not equal to null. So is my head next not equal to null? Yes, my head next is not equal to null, because my head next is pointing to 7, right? Then it will get inside the loop and check this condition, which is if my head key is equal to key. Is my head key equal to key? No, my head key is equal to 4, and the key value is actually 7, so they are not equal, so the while loop will not break. Again the next line will be executed, which is previous is equal to head. So the previous will now be equal to head, which is 4, and the head will be pointing to head next according to the next line. So head next is 7, so head will be pointing to 7. Again the loop will start. Now this condition will be true. Sorry, this condition will be false. So my head next is equal to null, right? As you can see, my head is pointing to 7, and this head next is pointing to null. So head next not equal to null will be false now, so this loop will break. But remember, we still haven't checked whether we found our key or not. We just learned that we reached the end of the linked list, so we will stop here. So this condition now comes into play, because this will check whether we have reached the end and whether we have found the key or not. So this will be true now, because my head next is equal to null, right? But the head key value, this key value, is it not equal to key? No, it is equal to key, right? Because this is 7 and the key value is 7. So this will not be executed. This line will not be executed, it will break. So the previous lines that we have already executed in the last iteration, that is the previous next is equal to head next, this line will be executed. So the whole function will continue as if it found the key. But if my head key was not there, that means the head key is not equal to key, then it will print that the key is not found and it will break and it will not execute these lines. So as we found the key, so it will execute these lines. So what will happen now? The next value of the previous value will be pointing to null, because let's again see what happened. Why does this happen? Because the head next, my head is pointing to 7 and my head next is null, right? So if this line is executed, which is previous next equal to head next, then previous next, that means 4, this 4's next should be pointing to heads next, and heads next is null. So 4's next should be pointing to null, right? So this is what happens. 4's next is pointing to null, and then we are going to free the head. So what happens now? The head is freed, and this is the result. So if the function terminates now, the entire linked list should be something like this, which is -333, 4 and null. So let's try to delete the last node and print whether this actual thing is printed or not. So we're going to delete a node which is 2. Then we're going to give the key of the node to be deleted, which is 7. So it should be deleted, right? Let's check whether it was deleted or not. So we enter 4 to view the nodes, and as we can see, the linked list was printed as -333 and then 4, which is what it is supposed to print. So it is working properly. Okay. So next we're going to see the last thing, which is editing a node. But to edit the node, we need our previous linked list. Okay, so we are going to again insert the nodes. So as we can see, the order is okay, right? -333, then 4. So now all we have to do is insert 1, which will come after 4, then 7, which comes after 1, right? So let's add a node, and the value to be added is 1. So instead of viewing, we'll again add, and the value to be added is 7, right? So let's add it. So now let's view whether it is printing the linked list or not. So it's printing -333, 4, 1 and 7. So which is the exact order that is here in this figure. Okay, so now we are ready to see how the edit node function works. So let's continue. So the edit node function is here. So if the choice is 3, then the node is edited, but now instead of 1 value like the previous 2 cases, we'll be taking 2 values, which are the key value that need to be changed and the new key value that needs to be placed inside or replaced, that the new key value that will replace the key value. Okay, so then the function will be called with 3 parameters: the key value, that means the previous key value, the new key value and the head. Okay, and the function is here, right? So what are the variables? So let's go through them again. At first, the head, which should be pointing to the beginning of the linked list, then the key value, and then the new key value. So we'll be working with these 3 variables. Okay, so as you can see here in the function, these 3 values are passed as parameters. Okay, so again the traditional while loop. So at the very beginning, we have to say which key we want to edit, right? So we want to edit the last key. Okay, because that will trigger this case again. So this is the worst case scenario. So if you understand this, then it will be easier for us to understand the easier cases. Okay, so the key value is 7 and the new key value will be 5. Okay, so let's get inside the node, so inside the function. So inside the while loop, head next not equal to null. So my head should be pointing to the very beginning of the linked list. Is my head next equal to null? No. So the while loop condition is true, it will get inside, and now my head is equal to head next. This line will be executed. So my head is equal to head next, which is 4. Now this condition will be checked. If my head key is equal to key, then break. So is my head key equal to key? The key value is 7 and my head key is 4. So this is not equal to 7, right? So it will not break. So again the loop will be executed. that means the condition will be checked. Is my head next not equal to null? My head's next is equal to 1, so my head's next is not equal to null, so then loop will be executed, and inside the very first line is head is equal to head next, right, this line. So my head will be equal to head next, which is 1, and then this line will be executed if my head key is equal to key. So again my head key is not equal to the key, right? My head key is 1 and the key is 7, so it will not break, and the loop will again start from the very beginning. So I will check the condition again, the while loop condition, head next not equal to null. Okay, so is my head next not equal to null? Yes, my head next is not equal to null because my head next is equal to 7. So we'll get inside the loop, and this line will be executed. Head is equal to head next, so the head is pointing to 1, so now it should be pointing to head next, which is 7, right? Now inside we'll check whether my head key is equal to key or not. Okay, so now my head key is what? 7, and the key that I need to change is 7, right? So they are equal, so we found our match. So this loop will break, and then this condition will be checked. So is my head next equal to null? Yes, my head next is equal to null, but the head key is also equal to key value, right? So this condition will be false, which says that my head key cannot be equal to the key. So if this was true, that means this key is not equal to 7. That means we are at the end of the linked list, but we did not find the key. Then again, just like the delete function, it will print the key is not found. Okay, but now as this part is false, that means we found the key, so this will not be executed, and this line will be executed, which is my head key value is equal to the new key value. The new key value is 5, so the last value will be replaced with 5. Okay, so if this is properly executed, then the result will be something like this, which is minus 333, then 4, then 1, then 5, right? So we go back to our execution of the code, and the previous part we already saw that it was printing minus 333, 4, 1 and 7, right? So now if we edit the node, we want to edit the node, so we will give the choice 3 and the value of the node to be edited, which is the key value 7, and the value of the new key, which is 5, right? So now it should be edited. Let's check whether it's actually edited or not. So let's give 4 to view the nodes, and as we can see, the value has been changed. Why? Because we replaced 7 with 5, and as we can see, it prints minus 333, then 4, then 1 and 5, which is exactly what this figure is showing. Okay, so that was actually the end of the edit function experimentation. Okay, so we are going to exit the code here. Okay, the process was executed. So that was also the end of my lecture. Okay, so if you have any questions, please ask. Okay, you will not ask questions again, but you will not even understand anything again. So I'm requesting you to ask questions, as I have given you many platforms to ask questions. For example, you can give comments in the Google Classroom, then you can give comments in my YouTube channel also, or my YouTube videos. I will try to answer them anywhere you want. And if you're worried about asking questions in front of everyone, then you can also ask me questions using Kubul. I believe I've already given the link in the Google Classroom. Okay, so please ask questions and try to understand the videos. If you do not understand, then the questions will be your only options of understanding. Okay, and if you don't understand, then I guess you'll have problems later on. Okay, you'll understand soon when you see your marks, although many of you got pretty good marks, but maybe because I gave more marks than usual. Okay, so this is the end of the video. So assalamu alaikum and stay safe.